So, start looking at monitoring. This will take some time. So, some of these concepts that we have looked at preliminary in a very simple fashion will also apply here. So, the purpose of monitoring, the monitoring is the main step. So, because anything we want to do, we have to measure. The first step in the environmental sequence of things that we talked about is monitoring. We have to. So, there are different objectives of the first thing you want to decide or to discuss is what are the objectives of monitoring. You can't just go blindly into a monitoring scheme without knowing why you are doing it. So, what is the objective? So, the objectives are in terms of could be many things. So, as we go further into the topic, we will refine this definition, the objectives. So, right now for many of you it may not be very obvious what the objectives could be, but we will discuss that very quickly. So, let us take the instance of say I want to I am looking at water. Okay. For instance, we are taking the case of water. Okay. Why do you want to measure water quality? And we had discussed this long back in the beginning of this. We want to measure water quality because we are worried that there may be any health effects from it. So, we would like to look at the water quality from a point of view of health effects. So, which means that we want to look at some target components in the water which we know have a problem, we have a problem. Okay. So, so when we do monitoring, implicit in monitoring is this issue of sampling. Yeah, what do we mean by sampling is monitoring is you are measuring a component or multiple components in a given sample of water. For example, we are talking about water, therefore it's water. But then what water that we are we where do we sample? What water should we take, and what are the problems and questions that we need to ask in terms of this? So, there is a very widespread. So, for simple example, you want to drink water, what water will you sample? You are going to sample whatever you are drinking. Okay. So, if you are drinking tap water, you will sample tap water. Yeah. If you want to drink tap water, you will say, is tap water safe to drink? Therefore, I will sample tap water and find out if the components are there, what is the composition and what is the concentration of these things, and therefore, I will decide whether tap water is safe to drink. If tap water is not safe to drink, then I will look at packaged water and then test it and so on. So, we keep going back and back. See, so idea of monitoring is linked to the end use of this, and then we say is a particular type of water suitable for a particular application. Okay. Is it suitable for washing, is it suitable for taking bath, or is it suitable for industrial use and so on. So, these kind of objectives are very important. Okay. So, so one must ask a question. So, the objectives of monitoring requires us to ask a question, form the monitoring question. So, what is it that we want to do? So, the question could be, examples is the water potable? So, it is a very simple question. When we say it is potable, we are defining the quality of water for potability. So, in the CPCB website and the EPA website, you have these qualities that are listed there. That is what is potable water. Certain characteristics must be there, it must be below this value and so on. So, this is the monitoring question. So, this will lead to the other follow-up activity that we want to do. Is the water potable? Is the water suitable for washing? Is the water suitable for industrial use? and so on. So, if you look at this question from a point of view of how critical it is to ensure quality, you are decreasing in the order. So, you are saying potable water is the highest order, so I will keep it at the highest level. The rest of it is lower quality than the other. So, in any case, so this relates to where you are going to sample it and all that. So, this is end use water that we are talking about. So, we are also looking at sampling in the environment. Okay. When we say monitoring, we are also monitoring in the environment, which means we are going back further to the source of some of these things. We are looking at the environment itself. So, when we are looking at in the overall scheme of things, in the beginning we discussed, we have health effects that are observed in receptors, then we go and see what is causing it, which means we have to monitor what is it that we analyze the air, the water, food and everything. And we go further back and we say, is this there in the environment? It is coming from the environment somewhere. So, we have to monitor in the environment. So, which means that we are monitoring in, for example, we monitor water, we are monitoring rivers, lakes, groundwater, all these things, okay, and then oceans and so on. Then we look at air, and we can look at soil, we can look at sediment and so on. Yeah. So, all this we are monitoring in all of this. Okay. So, when we monitor in a river, for example, the questions that we are asking, so we have to so, the first step in monitoring is sampling, which means you have to have a sample. The word sample is a reserved keyword. Sample means it has a special status. Sample is whatever is it that you want to analyze anything in, that is a sample. So, what constitutes a sample determines what information you get out of it and what you make out of that, how do you interpret that information. So, sampling, in order to give you a sample which is, we will do analysis and interpretation. Okay. For example, if you are looking at, my objective is is the river water safe for drinking? Yeah, very simple question. By experience, we may know that it may not be safe for drinking, but a priori you do not know. So, if say 100 years back, people used to drink directly from rivers and all that, 200 years back or whatever time back. So, but this is a valid question. So, now, so the follow up question will be, is or other questions will be, is the river polluted? Yeah. Okay. Now, in this question, so where will you sample? So, I have a river that is flowing. Then I need a sample of water. I need a sample of water from this. So, where will I sample? Yeah. So, the question is, sampling location. Yeah. Where will I sample in a river? I have a lot of choices, right? I have a lot of choices. So, if my question is simply, if my question, objective of the objective question is simply Is the river polluted? A very general question. Where will I sample for this? Huh? Anywhere. Okay. So I will, let's say I will sample here. This is my sampling location. I take the water out of this, and then I go through the process of analyzing. I will get some results, and let's say I have some concentration. Let's say based on the concentration, I determine that it is polluted. Okay. It is polluted. But is this a general answer? Does this give you, is this a universal answer in the sense, what will you do with this information? So, you determine that it is polluted from sampling here. So, you go and tell the, whoever is the agency that controls the river, they say this river is polluted, then what will their response be? If you are a user or you are a regulator and administrator, what are the other questions that you can ask? Find the source of the pollutant, yeah. Find the source of the pollutant. So, that becomes a new objective now. So, how do you find the source of the pollutant? By using monitoring. You have a secondary question that has now appeared. Based on this polluted, you will find what is the source of pollution. Now, this is now a new sampling objective. What will you do now for this? Where will you sample? This is a difficult question. Where will you sample now? Naturally, from a very simple common sense point of view, where will you sample? This is a river, which means where will you sample? You have upstream. So, where you sample? Very simply, you sample before here or after here. Two possibilities, either here or here, this one or this one. So, you can, why do you think upstream is more useful than downstream? Yeah, it is flowing, so it's flowing somewhere. So, if the pollutant is here, it's coming from somewhere else. So, we would like to find out where is it coming from. So, what would you do? How will your sampling plan now be? Very straightforward question. You don't need to be an engineer to answer this question. Simply what would you do? How many samples will you take? 2? You take it here. What are the possibilities of the answer that you will get from this point? What is the question you are asking here when you sample? Here you are right now the first point, as first sampling point, I have taken the water and I am determined if it is polluted or not. I have said yes or no, it is polluted or not. Here sampling point number 2, I will ask the same question, is it polluted or not? Which means that I am applying some quantitative criteria to ask that question itself. When I say is it polluted, itself my question is the concentration of water greater than some concentration of some standard? This is the question I am asking. I am determining this information, I am comparing it with something, and I say it is more than what is acceptable, therefore I consider it as polluted and done. I am doing the same thing here. What if I find that rho A2 is almost the same as rho A1? Then what will I do? What can I do? I will go further, I will take one more sample. So I have to keep going. I keep going and comparing this again, rho A2, sorry, this is rho A2 1 and this is rho A2 2, this is rho A2 3 and so on. I keep going further and further down until the point when I see that some rho A2 n is less than rho A2 n minus 1, or it is much less than rho A2 n minus 1, and also or rho A2 standard, either of these things. Then I know that somewhere between, say, let us say that rho A2 3 is much less than rho A2 2, which means that somewhere in this region my source is in this region. Okay. So, this is an investigative process in which what are the constraints here? So, let us say that I have a river that is where I find first sample I do here, I find pollution, right. How far can I go? You have to make a decision that the second sample is how far from the first sample. What is the easiest way for me to do it? Simple, no thinking. What would you do? Physical examination of what? So, you have to go, so theoretically I can go do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, keep on going. Say I will do every sampling every 100 meters. Okay. Is this necessary? I can do 100 meters, every 100 meters I can sample. So, the assumption here is that within 100 meters there is some source that may be coming. So, what she is saying is, instead of doing it randomly at 100 meters distance, you go and look what is there on the shore, both sides, what could be possible sources of contamination. There are physically anything that can contaminate. So, we call these as point sources. Point sources is applied in air pollution predominantly, but this is what we are calling here the point source for water pollution, which means that there is a fixed source here. Fixed source means there is, say, a factory, there is an industry or something, some manufacturing plant, and there is a possibility that this will go here. Now, you can make a judgment very easily. So, one of the things you have already done, you already have information of rho A2, which means you already know what this A that you are looking for. A is some pollutant, right, something. In the scheme of things, I can do an analysis for hundreds of chemicals and I say that this is there, A is there. When I say rho A2, it does not mean only one parameter, it means we are doing entire analysis. I am analyzing for say 100 parameters, 100 chemicals, metals, non-organic, everything, microorganisms, everything. So, I know that there is a possibility of A, this is one of these components that has now caused health effect, can cause health effect. Where can that come from? So, this A is linked to a particular source. For example, if you find mercury in the water, there must be some source of mercury that is appearing in the water from that is contributing to this. So, then you go and look along the river, is there any process that can contribute mercury? Okay. So, this information is needed, is external information. This information involves you to know, you can list what are the possible sources, point sources. You have a list of industries, there is one industry is battery industry, or there is a company that is making bulbs, or there is a company that is making something else, electrical components, all these things. So, there are components, you can make a list of these things and then say possible emission of these things. So, therefore, then you do not have samples. Say, let us say a factory is here, I can skip all of this, I can go directly to something upstream of this factory. So, my question now is this factory causing the pollution, which means that I will sample at one, the second sample now will become here or somewhere little upstream, and then I will say, is this, if I ask the question, if factory let us call it factory 1, source of A. If rho A2 2 is less than rho A2 1, the answer is yes or possible. See, the answer is never yes or no, very, it is not that straightforward. Okay? We will come to that in a bit. Let us say yes, possible. When you go and do so this is one answer. So, when you get results like this, immediately you know, and you go and sample further upstream, little more to confirm that this is true. Okay. And then this is true, then you again confirm it again, you see it is happening again and again. So, this is sampling objective. So, then we make a statement that factory 1 is responsible for this contamination. So, the objective of the sampling initially is to just find water quality, and then it has converted into finding out the source of the pollution. And then further it has also, once you find, in this problem itself our questions started from, is the river polluted, to it became a secondary question, what is the source. Then the third follow-up question is, we are confirming it's a source. All these three questions need sampling, but the objective has changed in each of these questions. Now we are looking very closely at very different things. In the first question, is the river polluted, is a very general question. I have no idea what I am looking for. So the first question itself can be, you can modify nicely by doing the analysis along the river, all the sources you can already do, and then say these are the possible pollutants already. I know the information that this is going to happen. These are the pollutants that are likely to come into water, and therefore look only for them straight away. I might define my water quality criteria based on that. Okay. Why would one want to do this? So, if this government, you are a government agency, you have so many rivers and so many lakes, so many things to take care of, you cannot go and keep doing individual analysis. So, you are generally looking at water quality as an overall parameter. So, you will not be doing 100 chemical analysis on that, you will generally be doing COD or BOD, and generally you will say that some water quality is not as good as what I would like it to be. I do not know what it is, I will leave it there. Based on that limited information itself, you can say that one particular source is contributing to the water quality impairment than the other, without even going to very specific information. For example, in the previous case, here I am looking at A. This A can simply be COD or BOD. It need not be a specific chemical, and this could still be true that the COD here is much lower than the COD here, which could still mean that factory 1 is polluting. We just do not know what it is. But here we are not doing a very specific matching, in the sense we are not saying A is particular chemical and this chemical is coming from factory 1 and therefore it must be factory 1 that is polluting. We are saying factory 1, there is a factory, so it may pollute, let me go and check. This is the level of this thing we are doing. Okay. Okay. The other type of sampling objectives that you can have is, this is much more easier to understand if you are looking at air pollution. Okay. So, because there it is much more complicated. A river is very straightforward, going from point A to point B. Yeah. Atmosphere is much more complicated. So, let us say that we always say air sampling, do air sampling. Yeah. Where will you sample? That is the question. This question of where you sample becomes very, very critical in air pollution, because of the nature of the way air moves. You can't even see it, first of all. You can feel it, but it does not mean anything. So, then the objectives become very, very important. So, in the case of air pollution, you see a lot of statements about air pollution in the public media all the time. Again, people take information that you give and use it for whatever people want to use it for, or whatever they understand. It is not really a mistake, but it's not an intentional thing, but sometimes you do not know what it is, because you are not aware of the system. Okay. Give me a few objectives, air pollution monitoring objectives. What could your question be? How will you frame your question? Same type, what we did in the same rules apply, same concerns apply, but the way in which we do becomes more critical. The sampling and monitoring becomes very critical here, and the assumptions that we do. And it is also true for water, and we will go back to water a little bit after we discuss this, and then we will refine that a little. Okay. Now, let me give you an example. Let me give you a simple example. We have a road in front of this building. Okay. If I go and sample the air outside this building, what will that data mean? There are a number of follow-up questions to this. Okay. What is this data? What does it mean? If I sample, if I go and sample there, I will give you a number. I will say PM10 concentration is, I will say 105 micrograms per meter cube. Okay, some number. What does this mean? Well, that has to mean something. I am giving you a number, it has to mean something. What does it mean? No, there is source, yes, but what does this concentration mean? Huh? There is standard, so let us say that it is greater than PM standard. Yeah, but in essence, when I am doing this sample, yeah, what is my concern, follow-up concern? So, what is the simplest inference I can make from this? It's a health effect. I am saying yes, it's causing health effect. Then what is the follow-up this thing? What is the source that is there? But before that, when you make this thing, we talked about this. What is the source? In the case of before we go to the source itself, what is the difference between the river and air? There is a river that is in this direction, going in this direction, and there is this general air mass that is in front of a building in a road like this. So, which means that we have tall buildings and there is a road that is going in between, and there is another tall building here. Okay, so there is a road going in which there are a lot of buildings, and I am sampling here, and this building is say 3 stories, 4 stories high. When I sample here, what is the, if I say this is polluted, what does it really, can I extend it to anything else? Huh? Wind direction. The wind direction, I will measure the wind direction. Let us say the wind direction is in this direction. Yeah. What does this represent? A concentration of 105 micrograms per meter cube. What does this represent in general? Because the objectives of the sampling become very important here. The difference between this system and this system, do I know everything about this system? The air system that is happening, that is present in this particular thing. This one I know a lot more information about this than this, because I know there is a river, there is a flow, and I probably know the flow rate, which is common, which can be measured easily. Here, if I want to know what this means, what could this mean? Let us put the question this way. What could this mean? One is, you have already said it is polluted, that is fine. Anything else that you can infer from this piece of reading? Let me give you a contrast. Suppose I go and I am sampling here, I go and sample on top of this building, and I see, I get a PM reading of 65. What does it mean? Then I sample between these two buildings, like between these two buildings, I go and sample here, I get a reading of 180. These three are all very close together. The distance between each of these sampling locations is hardly 100 meters from each other. But there is a difference big difference, there is a possibility of a big difference in the reading of these three samples. What does that mean? Huh? Flow rate of air may be different. Okay. So how does that change the concentration? So if this is, if you see such data, what is your next immediate thing? What will you do? You can't make sense of this data. Which one will you report? Which one will you report? We are coming back to our objective question. Which one will you report means then my question will change again. So which one will you report? Why not? Why not on the top of the building, and why here? And why not here? See, depending on which way I want to turn the debate, I can say that I can use this number and say it's very polluted, 180, very highly polluted. So ban. So then you will go and find out what the source is, and then you say I will ban all vehicles on campus, I will ban this, I will ban that, everything is closed, done. But then what does this mean? This 180 here means it should mean something. Why not? Why not? This is 100, this is 180, and this is 65. Somebody else can use 65 as a value and say everything is fine, no problem, everything is okay. This is a problem. This presents a very important question in terms of why you are sampling and what is the objective and what is that meaning, what is the meaning of that particular value. Yeah. So there is something more to this. What is that? I am trying to ask you what is that? So very simply, this is true to all analytical studies. You cannot make an inference from one particular sample, which is why all environmental scientists do what is called as a time series. Especially in environmental systems, because we don't know why something is happening. If you know everything exactly why something is happening, then you can find out exactly why, what is the cause of a high concentration or a low concentration. If we do not know why it's happening, but we still can't stop doing anything, we have to start. So we do what is called as a time series. So in order to understand this, so very simply, the information about these three can be sorted out by looking at the second question that we did. We look at what is the source, what are possible sources. Okay. So here, is there a higher source than what is there in this case? So we call it as again sampling location 1, 2 and 3. So is something in 1, there is something in 1 that is not there at 2, and there is something at 3 which is not there in 1 and 2, or there additionally there is something there in 3. So this is at ground level, this is ground level, this is up to about 3 stories high, about 100 meters high, and this is 100 meters away, but it is inside somewhere. So this is exposed to some sources. There are vehicles going here, and you can say that 100 is because there are vehicles happening. The vehicles are the source of this pollution. Yeah. So this is an inference you make. The vehicles are a source of this pollution. What about this one? What about the 65 here? This, second one, up in the air, top of the building. There are no vehicles nearby. If this was also 100, then you can say that whatever is happening here is seen here also. So this source, whatever the source that is contributing to this, also is contributing to this, possibly. The only way to confirm that is you keep doing this again and again. It will happen to this. Variability of this location or space, this means something. So in this case, we are looking at 3 different locations, sampling A, which is on the side of a building, sampling 1, then we look at sampling site 2, and then we look at sampling site 3, which is in between, on the ground. This is on the ground, this is 100 meters elevation, this is on the ground in front of a road. This is no road here. We say it's 100, 65 and 180. It means that you can go and look at some specific activity that's happening. It's quite possible if there are no. So what we do is, if we look at this is to understand this variation in space, we have to do a variation in time. We do a time series. So with sampling location 1, we are looking at time series, which means we are looking at, say, it's 50, 100. Suppose we get data that looks like this. Yeah. then sampling location 2, 50, 100. Let me draw it on the same this thing. You can draw it with a different color. This is sampling location 1. I will draw sampling location 2. 3. It's quite possible that for 3 I may find this. What does this mean? 3 is low, there are not many sources, but once in a while this suddenly you get a big spike. Okay. So, from this kind of data, what inferences can you make? Is there is a reliability to this data, in a sense you are doing time series. So, when we say time series, I do it for say 30 days, I am measuring it for 30 days, 1 month long. I am saying that there is variation in the data, but more or less if I draw a line, I can draw some kind of a mean line here. Okay. It's an average, and I can also draw a line here and say that approximately this is what is happening, the average here. For this blue line, the average is going to be very small, it's going to be small compared to this, but there are some big spikes, here that have happened. So, when you look at data, when you sample, when you find an anomaly like this, when you cannot make sense of the data, you have to go and do a time series. You have to do that. You can't sample once and say, oh, site number 3 is more than, you can't find any reason why it should be. What possible reasons could there be that there is high, at the time when you are monitoring, if there is a high concentration, what possibilities exist? What are possible reasons? Can you, from this your observation of activities here around this building? I can defend this, I can defend sampling 1 that is higher than sampling 2, because sampling 1 is closer to some of the sources which I think are contributing to pollution than sampling 2. Sampling site 2 is up in the air, there are no big sources nearby and it is far from the ground, and therefore I do not expect much this thing. Okay. It is observation, this is based on observation. So, when you are living in a house which is on the ground floor versus second floor or 10th floor, there is a lot more dust that comes in the ground floor than in the 10th floor. We will get to that later again, whether that is really how much, what does that mean? And this is not a blanket statement, but observationally you can at least rationalize it. You can say that I know how to explain it. It makes sense. So, there is a spike, very special activity that is happening say once a week. Okay. So, it could be things like people are sweeping that entire area and cleaning it. Sometimes people clean roads. They clean roads by taking a blower and they blow. Okay. That's possible. So, in IIT they sweep. In this campus they sweep. So, when they sweep, there is a lot of dust locally for a short period of time. So, in that time if you are sampling, you will see a spike, but it does not happen anymore. So, between these two buildings people sweep, they sweep on soil which generates a lot of dust. If you are doing sampling during that time, you will see that spike. It does not mean there are any other sources, it is not a recurring source, it happens once a week or once in 2 weeks or so. So, this is very important for you to make judgments like this. A sampling objective has to be designed, you can't take any inference from one arbitrary reading. The arbitrary reading is just a test, the first step in our sampling thing. You say, is the river polluted, is the air polluted? Yes. If it is yes, then you have to confirm by time series analysis. You also have to confirm by variation in the space, with space, which means, say in a river, I have to sample multiple locations initially itself to get some variability in space. I can also sample close to the shore, away from the shore. This may also mean something, okay, because rivers have a structure. It's not constant flow throughout. No, there is some flow. There is variability of flow in the middle versus that in towards the shore. All that is possible. and there could be something else near the shore that is causing a slight difference. So, these are all more refined questions of where you must sample. Again, same questions appear for lakes also. Now, when you go to groundwater, okay, groundwater is under the soil. This is the groundwater. This is the groundwater. How do you sample groundwater? You have to access it. So, what is the only way to access groundwater? Through a well. You have to dig a well, and the sample water will come up a little bit, and you sample the groundwater. Here also, when you dig a well, water is already here, right? If you want to sample this position, how can you do that? There is no well there. If you want to sample water that is there actually in the groundwater, it is quite possible that this section, there is water, some amount of water in the well already, and it is sitting there for a long time. It may not represent what is the groundwater quality here. So, you have to pump out this water and wait for that some time for this water to come up and then sample. So, this is very important. So, this groundwater is much more tricky because you are not able to access groundwater wherever you want. The air sampling, I can go wherever I want. Technically, there is nothing stopping me from doing it. I may have to spend more money to go and sample at a particular location in the air or in the water also. The groundwater is difficult because I have to essentially dig up the entire thing and reach the groundwater. So, I can't do that. I have to draw a well, which means I have to draw multiple wells. I have to keep on putting hundreds of wells in the area. That is the only way to do groundwater analysis. If you are looking at the same question that we asked in the river, where is the source? Groundwater here is polluted. You have to find out where is the source. The source can be anywhere. The groundwater is not like a river, small flow. It can be a large section that is floating around. So, you have to go and make wells in a given area and then make a map of the concentrations and then figure out where the source could be. And it is much more complicated. You have to understand the hydrology, and this is where the analysis of transport comes into question. So, there is a field in monitoring and chemical analysis which is called as environmental forensics. This is a very niche field. Niche field means it is a very specific thing. You are calling it forensics because the word forensics means something nefarious. We talk about forensic in a crime scene analysis and that kind of thing when we are talking about police investigation. This is an environmental investigation, which means that it will answer questions. Primary question that we are asking is, where is the source? What is the source? And the source information, to find out where the source is, we are making use of this information of the flow of the river to figure out, to guess that the source is upstream or downstream, and we are looking at the composition analysis of the chemical to find out whether that source will come from a particular, whether that chemical comes from a particular source. So, these two pieces of information that relates to the chemical analysis, the composition itself, what we call as a signature. A signature, if a signature appears in the sample, you know that that signature is corresponds to one particular source only. And then we have transport. The signature is also called as a biomarker, a marker. It's a marker. Signature is a marker. So, some things have markers. So, transport. So, how will it move from the source to the point that we are looking at? So, this transport model is very useful in predicting where it comes. So, this is a simple transport model. Flow of river water is going from point A to point B. It will go. Likewise, if you are able to model groundwater flow, you can figure out where will it come from, where is it coming from. If the concentration is changing in a certain manner, you can backtrack and say this is where it is probably coming from without even measuring. So, that is the idea. Why are we worried about all this number of samples and using other information to do all this? Why are you worried about it? Why don't I don't care. I will put 1000 monitoring wells and sample. Huh? It is time and cost, both. It's very expensive. Time is there, but the expense is the more important. It costs a lot. You will see how much it will cost depending on how we do the analysis and extraction. The cost part of it is also very critical, because a lot of the information that you gather from sampling and monitoring is used for what we call in assigning liability. It's a legal thing. It means that if I find the source to be factory 1, I am charging factory 1 is polluting the environment, then they have to do something about it. They have to pay a price, they have to pay the penalty of cleaning up the river, or just a penalty. So, regulatory agencies will shut the industry down, or they will give a large penalty and all that. So, which means that you have to be able to prove you are giving a number to somebody. You have to show that this number is correct, liability, which means you have to make extra expense to make sure that your number you are giving to people is correct. It means you have to do more quality assurance and all this costs. Quality assurance and quality control, all this costs money. The more, so you have a lot of confidence in the number you are giving, the more it costs. So therefore, this is all expensive, and therefore people try to use a judicious combination of the environmental forensic principles in order to prove that this is what it is.